Hello friends, welcome to video lecture on CPT Quantitative Aptitude, Chapter 11, Measures of Central Tendency. Now we are going to discuss on the topic median. Myself, Dr. N.V. Ravi, I am mentor for this section. In this section, we are going to discuss the importance from real life and examination perspectives of the topic measures of central tendency, median. Generally, for this topic measures of central tendency, 3 to 4 marks an average of the CPT examination will be coming. Students, friends, now we are going to discuss the measures of central tendency. In this, the median is the category. As compared to arithmetic mean, median is the positional average, which means that value of the median is dependent upon the position of the given set of observations for which the median is wanted. In general language, median means middlemost value. And we have been already discussed, median is the positional average, and which means that value of the median depend upon the position of the given set of observations which you want to compute. And median is general scenario we call as middle most values, and which is computing by the middle value after the data is ordering either in ascending order or descending order magnitude. We have to decide whether the data is in increasing order, or we have to decide the data to arrange whether it is in the increasing order or decreasing order. We have to first order the data according to the magnitude of the observed data. Now, in the coming slides, we have to discuss about the examples about the median when the data is an even number of observations and odd number of observations. Now, coming to the data, which is raw data, and here the observations are odd number of observations. Let us look at the example. If the marks of the 7 students are 72, 85, 56, 80, 65, 52 and 68, then find the median marks of the students. Now we have to find the solution for this, that is median. As we have already discussed, the median refers to the middle number of observations. First, here the number of observations is 7, which is odd. First, see the data, which is odd number of observations, Then second step is we have to arrange the data in the magnitude of increasing order. See, look at this data first. Which one is the smallest, and accordingly we have to arrange the data. One is 52, second one is 56, 65, 68, 72, 80, 85. These are the data which is raw data. We are arrange the data into the ascending order or increasing order. While finding the median for odd number of observation, if the number of observation is odd, the median equal to n plus 1 by 2th item. That is 7 plus 1 by 2th item, that is 8 by 2, that is 4th item. In this category, 1, 2, 3, 4th item is 68. Therefore, 68 is the median for the given data. Students, even in the examination also these kind of examples are very important. When you want to compute the median for simple data, let us first look at the number of observations are odd or even. In the case of odd number of observations, just first arrange the data in the ascending order. After that, you find the n plus 1 by 2th item, then decide the median value. Friends, in this example, we are going to discuss the median in the case of even number of observations. Let us look at the example. If the wages of 8 workers expressed in rupees are 56, 82, 96, 120, 110, 82, 106, 100, find the median wages of workers. Now, the given number of observations are 8, that is even number of observations. Let us look at the solution. Now, first we have to arrange the data in ascending order magnitude. Here, the data are rupees 56, rupees 82, rupees 82, rupees 96, rupees 100, rupees 106, rupees 110, and rupees 110. We all know in the case of even number of observations, median can be computed as it is the average of n by 2th item plus n by 2 plus 1th item. In that category here, it is average of, that is 10 by 2th item, here sorry 8 by 8 number of observations, 8 by 2th item plus 8 by 2 plus 1th item. In this, here the average of 8 by 2 is 4th item plus 5th item. This is purely the 4th item is 96 and 5th item is 96 plus 100 by 2, which is 196 by 2, which is rupees 98 is the median for the given number of observations, which is related to wages of 8 workers based on the even number of observations data. Now, in this slide, we are going to compute the median for the grouped frequency data. In that case, here median for the data, the class interval and frequencies are given. The data is as follows: 350 to 369, the frequency is 23, 370 to 389, 38, and 390 to 409, 58. 410 to 429, 82, 430 to 449, 65, 450 to 469, 31, and 470 to 489, 11. The frequencies are given. Here, if you look at the data is type of array, class interval, inclusive class interval series case. Now, before computing the median for the grouped frequency distribution of the case of median, we have to just briefing about the formula how to can be computed. This is equal to L1 plus n by 2 minus NL by NU minus NL into length of the class interval. Now, I have to explain the one by one categories. L1 is nothing but lower class boundary of the median class. Lower class boundary of the median class, and n equal to total frequency, and NL equal to less than cumulative frequency corresponding to NL equal to less than cumulative frequency. Cumulative frequency that corresponding to L1, that is pre-median class, and NU equal to less than cumulative frequency corresponding to L2. NU equal to less than cumulative frequency corresponding to L2, which is post-median class, which is pre-median class. And we all know that C is the length of the median class, which is L2 minus L1. That is length of median class. Students, just before computing the median in the case of grouped frequency distribution, just look at the formula. Median equal to L1 plus n by 2 minus NL minus NU minus NL into C, where L1 equal to lower class boundary of the median class, n equal to total frequency, NL equal to less than cumulative frequency corresponding to L1, which is pre-median class, NU equal to less than cumulative frequency corresponding to L2, which is a post-median class. In this slide, we are going to compute the cumulative frequency distribution, which is exhibited in this following table. Now, the class boundaries are, the earlier example, if you look at the table, the previous slide, where to, that is the case of inclusive class intervals case, then 0.5 is subtracted and 0.5 is added to the upper boundary. That is 349.50, 369.50, and 389.50, 409.50, 429.50, 449.50, 469.50, 489.50. This is the data, and we have to find the less than cumulative frequencies First one is 0 and second one is 23, 61, 119, 201, 266, 308. First we have to look at the data. The data is of the type inclusive class interval type. First we have to convert the data like the class boundaries, that is in the less than cumulative frequency case. Here the data is inclusive class intervals. First we have to subtract 5 here, 0.5 here, and 0.5 is add. And in that case here, this will be 349.50, and 0.5 is subtracted here. This is a 369.50, 389.50, 409.50, 449.50, 469.50, 489.50. First, it is in the case of less than frequency distribution. First, we have to assume the first value is 0, and next one is 0 plus 23, 23, 23 plus 38, that is in the case of that 61, and 61 plus 58, 61 plus 58, 119, 119, 119 plus 82, 201, 201 plus 65, 266, 266 plus 31, 297, and 297 plus 11, which is 308. We have computed all these values in the cumulative frequency table, which has been computed in the second slide. Before that, we have to find out the value of n by 2 also. Here n by 2 is as much important. N is 308 and n by 2 is 308 by 2, that is 154. This figure is also very important to know the values of lower boundaries, upper boundaries. We have already computed in the last slide that n is 3 by 2 is 308 by 2, which is 154, which lies between two cumulative frequencies, which lies between the two cumulative frequencies 119 and 201. 119 and 201. Now we are assuming that this is NL and NU. And this can be written as 119 is less than 154 is less than 201. Thus we have NL equal to 119, NU equal to 201, and corresponding lower boundaries is L1 equal to 409.50 and L2 equal to 429.50. Now C equal to length of the class interval is this difference, that is 20, 429.50 minus 409.50, which is 20. Now we have to compute the median in the next slide. You all know median equal to, that is here the formula, that is L1 plus n by 2 minus NL my Nu minus NL into C. In this, if you look at the lower boundary value, L1 value is 409.50 and N by 2 is 154, which is NL is 119, and 201 minus 119, the length of the class interval is 20, which is further 409.50 plus, after simplification, this value is 8.5054 and 418.04 is the median in the case of the data is grouped frequency distribution. Now in this example we are going to discuss about the median when the data in the given data median mass is 23. Find the missing frequency from the following data given that median mass is 23. Let us look at the data. Mass and number of students are given. The mass are 0 to 10. Let us look at the data. Mass and number of students are also given. One frequency is missed in that category of 20 to 30 mass. We have to compute with the help of median. Now, suppose the F1, F2, F3, F4, F5. We assume that the missing frequency is F3. Now we compute the median with the help of less than cumulative frequency mass. The class interval category generally are less than category and more than category. Now, first we have to compute the data indicator of mass and less than cumulative frequency. First we have to assume the data 0, 10, 20, 30, 40 and 50. Like that way we have to assume the category of less than cumulative frequency. First one is 0, up to 10, 5, and 5 plus 8, 13, and 13 plus F3, and 13 plus F3 plus 16, 19 plus F3, and 19 plus 3, 22 plus F3. These are the important data before computing the median. Let us express the same thing in the second next table, which is helpful for further computing the missing frequency. Now, already we have been seen in the last slide, the data is 0, 10, 20, 30, 40 and 50. And the categories less than cumulative frequency are 0, 5, 13, 13 plus F3, 19 plus F3, 22 plus F3. Going through the mass of the column, we found that the median as given 23 and which is lies between 20 and 30 and 20 and 30. In that case, the category we assume that which is lies between these two categories. Assuming that which is L1, which is L2, and in that case the respective frequency NL and NU are these categories. Okay. Now, accordingly we compute the median as follows. Hence, L1 equal to 20, L2 equal to 30, accordingly NL equal to 13 and NU equal to 13 plus F3. 13 plus F3. And also the total frequency is N equal to, capital N equal to 22. This is the total frequency, 22 plus F3. Now we have to apply this in the formula M equal to L1 plus N by 2 minus NL by NU minus NL into length of the class interval. In this example, which is given that median is 23 and L1 is 20 and this N by 2 is 22 plus F3 by 2 minus 13 by 13 plus F3. This is 13 plus F3 minus of 13 into length of the class interval is 30. Now, before simplification of this calculation, let's look at 23 minus 20 is 3, and in the denominator part 13 plus 13 and minus 13 is cancelled. So the simplification of this sum is 3 equal to 22 plus F3, 22 plus F3, 20, 32s are 26, which is 2 5s are 10, 2 5s. So the simplification will be defined in the next slide. And this is 3 equal to 22 plus F3 minus 26 by F3 into 5. We have already discussed it in the last slide. And 3F3 equal to, that is 3F3 equal to 5F3 minus 20, 5F3 into 5F3 minus 20, that is simply 22 minus 24 is 4, 4 5s are 20, 5 into F3, 5F3, and this 3F3 is multiplied here, 3F3. 5F3 minus 3F3 is 2F3, 2F3 equal to 20 and F3 equal to 20 by 2, which is 10. Therefore, missing frequency F3, which is 10. Now let us look at the example. In this example, wages of the laborers rupees 82, rupees 52, 56, rupees 90, rupees 50, 120, 75, 75, 80, 130 and rupees 65. Now we have to find the quartile 1, decile 6 and percentile 82. Before computing these deciles, percentiles and quartiles, the importance of the partition values we have to look at. These are the defined dividing the data into observations to equal number of parts. Quartiles divide the data into 4 equal parts. In that category, first the quartile divides the data into 4 parts actually. 1, 2, 3. This is first quartile, second quartile, third quartile. First quartile is denoted by Q1, which is lower boundary of the class, lower quartile deviation. lower quartile. Second quartile is the data, divides the data exactly into two parts, and which is also called median. Third quartile is the we called as Q3, and which is called the upper quartile, which is Q1 is called the lower quartile, Q3 is called the upper quartile. And suppose the data divides the 10 parts, and which is called deciles 1, 2, 3, 4, 5, 6, 7, 8 and 9. Deciles are the values dividing the given set of observations into 10 equal parts. 10 equal parts. There are 9 deciles to denote, and which is 9 points are decided to divide the data into 10 parts: D3, D4, D5, D6, D7, D8 and D9. Accordingly, the data is divided. And in the case of, this is about the deciles, and in the case of percentiles, suppose the data, divided into 100 parts, we divide the categories 1 to up to 99 categories, 99 points. So we represent like P1, P2 up to P99 categories. In the case of deciles also, it is D1, D2 up to D9 categories. In the case of quartiles, Q1, Q2, Q3. The first quartile is lower quartile, the upper quartile is Q3, and the middle quartile, that is a median, second quartile, and which divides the data into two equal parts. In the case of D5 is the median here. In the case of percentile, P50 is the Q2. The Q2 are median. Now, coming to the example, in the case of computing median, quartiles, deciles, percentile for the raw data, first we have to arrange the data in the form of ascending order or descending order. Now we are going to compute the partition values like Q1, D6 and P82. Before that, we have to arrange the given data into ascending order form. They are 50 rupees, 56, 65, 75, 75, 80, 82, 90, 120, 130. These are all wages expressed in rupees. All are expressed in wages rupees. Now we have to compute the first quartile, that is lower quartile. Let us look at the data, the number of observations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here 10 number of observations. Median can be found, which is n plus 1 by 4th item. Here first quartile, that is n plus 1 by 4th item. Here this is not median, it is a lower quartile. In that category here, 10 plus 1 by 4, which is 11 by 4, 11 by 4, which is 2.75 item. In this category, we have to find the 2.575 value in the data which has been arranged in ascending order magnitude. Let us look at the data. The second value is 56 plus and 0.75 of the third value and second value, and 56 plus 0.75 into, here the third value is 65 and second value is 56, and in that category here 56 plus 65 minus 56 is 9 into 0.75, which is 6.75. Here the 56 plus 6.75, which is 62.75, is the rupees 62.75 is the first quartile. Now we are going to compute the decile sixth one. Already we have seen in the earlier slide. Once again I write here for the data in the ascending order magnitude. One is 50, 56, 65, 75, 75, 80, 82, 90, 120 and 130. Now we have to find the decile value of 6d6, that is n plus 1 by 10th into 6th. We have to find the value of 6th decile. If in the case of second, we have to write second here, second decile. If in the case of third, we have to write 3 here. So this is, we have to find the value 10 plus 1 by 10 into 6th value, which is 11 by 10, that is 6.60 value. That means in the category of 6th value plus 0.60 into difference between the 7th and 6th value. Difference between 7th and 6th value. Now, in the data, the 6th value is 1, 2, 3, 4, 5, 6th value is 80 plus 0.60 of difference between 7th and 6th value. 7th value is 82, 82 and 80 is 82 minus 80. 80 plus 0.60 into 2, which is rupees 81.20, which is the 6th decile for the given data. Now we are going to compute the percentile of 82 82 percentile. Again, we have to look at the data, given data, which is arranged in the ascending order magnitude, which is 50, 56, 65, 75, 75, 80, 82, 90, 120 and 130. While computing the percentile category P82, here we have to compute the for percentage of 82nd one, that is n plus 1 by 100 into which percentile you have to consider. So here 10 plus 1 by 100, here we are going to compute for 82nd one, 82nd value. That value is 9.02 value we have to find out. And this is ninth value of the given date plus 0.02 into difference of between 10th and 9th value. In that category here, 9th value is 1, 2, 3, 4, 5, 6, 7, 8. 9th value is 120 plus, and difference between 10th and 9th is 10, and that is 130 minus 120 into 0.02. In that category it is 120 plus it is 0.20, which is 120.20 rupees. 120.20 is the 82nd percentile for the given data. Now let us look at the properties of median. If x and y are two variables to be related, phi equal to a plus bx for any two constants a and b, then the median of phi is given by y of median equal to a plus of b into x times median. Properties of median continued. For a set of observations, the sum of absolute deviations is minimum where the deviations are taken from the median. This property states that summation of xi minus a is the minimum. We choose the median as the a is the median. In the case of a mean, the sum of the deviations from respective mean is 0. In the case of median, the sum of the deviations from the respective median is minimum. This is very important multiple choice question for the examination point of view. Now let us come to the multiple choice questions related to the topic median. Now let us look at one by one. For open-end classification, which of the following best measures of central tendency? Number 1, arithmetic mean, geometric mean, median, mode. In the case of median, open-end classification, which is the best measure of central tendency? Answer is the median. Second MCQ, in case of an even number of observation, which of the following is median? Number 1, any of the two middlemost value, the simple average of these two middle values, the weighted average of these two middle values, any of the sum. Answer for this multiple choice question is the simple average of these two middle values. Quartiles are the values dividing a given set of observations into number 1, 2 equal parts, 4 equal parts, 5 equal parts, none of these. Answer for these quartiles are the values dividing a given set of observations into 4 equal parts. Quartiles can be determined graphically. Number 1, using histogram. Number 2, frequency polygon. Number 3, OG curve. Number 4, pie chart. Quartiles can be determined graphically using the OG curves. Which of the following measures of central tendency is based on only 50% of the observations or values? You know very well, based on the median definition for these options, mean is not suitable one, mode is not suitable, both 1 and 2 also not suitable. So median is the right option for this question. What is the value of the first quartile observations? 15, 18, 10, 20, 23, 28, 12 and 16. For finding out the first quartile for this data, first we have to look at the data and arrange into form of increasing order, that is 10, 12, 15, 16, 18, 20, 23, 28. Let us look at the data. We have arranged into ascending order magnitude, and how many observations? 1, 2, 3, 4, 5, 6, 7, 8 observations are there. And for this observation, first we have to find the first quartile observation, that is n plus 1 by 4th item, that is 9 by 4, 2.5 item, that is second item, and plus 0.5 of difference between third item and second item. Second item is 12 and 0.5 into difference between third and second is 3 into 0.5, that is 0.75. 12.75 is the first quartile deviation. So for this data, the answer is third is the correct answer. The third decile for the number 15, 10, 20, 25, 18, 11, 9, 12. We have to find out the third decile for this question, and third decile is, first before that we have to compute this data for third decile. We have to arrange the data into ascending order magnitude: 9, 10, 11, 12, 15, 18, 20, 25. And let us look at the observation. There are 1, 2, 3, 4, 5, 6, 7, 8 observations are there. Third decile we have to find out 3 into n plus 1 by 10th item, that is 3 into 0.9 and 2.7th item, that is second item, plus 0.7 into difference of third item minus second item, that is second item is 10 plus 0.7 into difference of third item and second item is 11 minus 10 is 1. This is 10 plus 0.7, that is 10.70. So answer for this question is 10.70 is the third decile of the observations. Now MCQ 8. Two variables x and y are given. Y equal to 2x minus 3. The median of x is 20. What is the median of y? And in this case we have to find out 2 times of median x. We have to ignore this. According to, as per the properties of median, we have to look at y equal to, based on the properties of median, y equal to x minus 3, simply 2 into 20 minus 3, that is 40 minus 3, That is 37 is the answer.